Now we have a point what is called a special substitution. Now what exactly is a special substitution? It is basically concerned with specific formulae. We have come across logarithmic functions, how to calculate them, exponential functions, etc. But algebraic functions, but you may have specific type of algebraic functions of the form x square plus a square or any such thing. We have done one such function derivation in the substitution part, but we have more number of functions based on that. So this is all concerned with special substitution formulae. For example, you have dx upon x square minus a square is equal to 1 upon 2a log x minus a upon x plus a. So x square minus a square, and there is no root over here, it's log x minus a upon log x plus a. This can be found out by the process of partial fraction, the same way you get 1 upon x minus a into, all have been derived by the same process. So one of them would be a upon x plus a plus b upon x minus a. So using the same process, they have found out this particular value. So you get 1 upon 2a log x minus a. Dx upon the reverse, a square minus a square, it will be x square, it's 1 upon 2a log a plus x upon a minus x plus c. Okay, so these two are similar ones. Similarly, dx upon a square plus x square, which is the same as dx of a square plus x square or x square plus a square, the whole square, square root, is going to be log x plus root x square plus a square plus k or c. Similarly, this is going to be dx upon root x square minus a square is going to be the same as x square plus a square. It is x square minus a square plus k. This is the second form. This is a special kind of substitution process we have found. These two have been done by substitution methods. So hence we get log of root x square minus x square plus k. Okay. Then we have two more important. So remember, this is x square minus a square. This is root of x square minus a square. So there are two different formulas. Then we have x square plus a square raised to half. That is, you have root of x square. The previous one was 1 upon root x square plus a square. It will have one of the factors will be log x plus root x square plus a square itself, like in the case of 1 upon a square. But this will be multiplied by a square by 2. And before that, there is one more factor, that is x by 2 into x square plus a square, square root of that. Much the same way, this is the same as root x square minus a square dx is going to be x by 2 into root x square minus a square. And since this is minus, you put here minus. The previous one was plus, here plus. A square by 2 log x plus root x square minus a square plus k. So these have all been done. The last four of them have been done the process of substitution. Remember, we had done one case of how take root x square plus a square as t minus x, and then we did taking t and then we took derivative on both sides and did substitutions. Using the same process, these formulae have been derived. Now let's see how to apply these. Say for example, you have dx upon x square. We can take some example over here. Suppose you have dx upon x square minus 5. Suppose I have. Now this can be written as dx upon root 5 the whole square. So it's going to be 1 upon 2a. So it's going to be 1 upon 2 root 5 log x minus a. So it's going to be x minus root 5 upon x plus root 5 plus c. Even something like this could be valid. Suppose you have dx upon x square plus 4x plus say 1. This is actually nothing but dx upon x square plus 4x plus 4 minus 5, which is going to be actually dx upon x plus 2 the whole square minus root 5 the whole square. So eventually this is going to be again the same way, 1 upon 2a. A in this case is root 5. So 1 upon 2 root 5 upon log x minus a. X is nothing but x plus 2 in this case. Minus a, that is minus root 5 upon x, which is x plus 2 plus a plus k. Hence we get it this way. Here all the terms containing x are written in the form of a perfect square expression, x plus something the whole square, and hence accordingly we get it this way. So these are ways in which you can apply this particular formula. Say for example, let's see how to do this. Dx upon x square plus 4x minus 8. Now this can be written as dx upon x square plus 4x. We know there is a 4 over here. So if there is a 4, it's a perfect square expression. So we can even use the formula, the square term is nothing but half coefficient of x, that is 4, the whole square, that is 2 the whole square, 4. So that means you have to add a 4 and subtract 4. So you added 4, to subtract 4 you get minus 12. So eventually this will become dx upon x plus 2 the whole square minus root 12, that is minus 2 root 3 the whole square. So this is all the form x square minus a square. So it's going to be what? 1 upon 2a, that is 1 upon 2 into 2 root 3, that is 4 root 3 log x minus a, that is x plus 2 minus 2 root 3 upon x plus a, that is x plus 2 plus 2 root 3. So it's of the form 1 upon 2a, a is this, x minus a, x plus 2 itself is x, minus 2 root 3, x plus a, that is x plus 2, which is x plus 2 root 3 plus k. So this way we find out the value of this. Now suppose you have something like this. Now here it's not x square, so we need to take 2 common outside. So eventually you end up getting 1 by 2 into dx upon x square plus 3x and minus 4. Now this is the thing. Now square a square, this is 2ab. Now square term is nothing but half coefficient of x, that is half of 3. 3 by 2 the whole square. So you have to add and subtract 9 by 4. So eventually it is half dx of x square plus 3x plus 9 by 4 minus 9 by 4 minus 4. So you added 9 by 4 and hence you have to subtract also. So it's eventually half dx upon x plus 3 by 2 the whole square. This one on simplification becomes 16 minus 25 by 4. So it's minus 5 by 2 the whole square. So this is of the form x square minus a square. So it's going to be half into 1 by 2a. So that is 1 upon 2 into a is 5 by 2. 5 by 2 into log x minus a, that is x plus 3 by 2 minus 5 by 2 upon x plus a, this whole thing is x, x plus 3 by 2 plus 5 by 2 plus k. So this gets cancelled, so it's eventually you get 1 upon 10 into log x plus 3 by 2 is x minus 2 by 2, that is x minus 1, 8 by 2, so x plus 4 plus k. So we get 1 by 10 log x minus 1 upon x plus 4 plus k. So this is expansion of dx upon x square. So now we have this kind of an example, dx upon a square minus x square. As I told, suppose you have dx upon say 36 minus x square. So it's going to be 1 upon 2a. That is nothing but a in this case is going to be 6. So 2a is 12 log a plus x, that is 6 plus x upon 6 minus x plus c. In the previous one it was x minus a upon x plus a. Here it is a plus x upon a minus x. Hence we get it accordingly. Yes. Let's take examples based on this. So we have 33 minus x square minus 8x. So this is eventually dx upon 33 minus x square and plus 8x. So that means if there was 16 over here, half coefficient of x, half of 8, that is 4 square, 16. Right? So it's going to be 16 at right, but actually it is minus 16. So it has to be plus 16 because it is minus 16. So to compensate for that, it has to be plus 16. Now this 33 and 16 can be added. So we get dx upon 49 minus x plus 4 the whole square, which is eventually dx upon 7 square minus x plus 4 the whole square. So it's of the form a square minus x square. So it's eventually 1 upon 2a, that is 2 into 7 log a plus x. A in this case is 7, x is plus x plus 4 upon a minus x, 7 minus x minus 4 plus k. So it's eventually 1 upon 14 log x plus 11, and here it is 3 minus x plus k. So it's going to be 1 upon 14 log x plus 11 upon 3 minus x plus k. Okay, now we have one formula, dx upon a square plus x square raised to half. We have done so many examples. So we have, say for example, dx upon 25 plus x square, root of that. So it's going to be log x, which is going to be x plus a square plus x square, that is x square plus 25 plus c. Hence simple questions based on that. So for example, here you have this is actually it's dx upon x square plus 8x plus 18 raised to half. So it's going to be plus root of this 14. Okay. So again, now here it is going to be dx. What is this actually? Root x square plus 8x. Now here the square term is going to half the coefficient of 8, half of 8, the whole square, that is 4 square, 16. So there is a 16 already over here, so we take that 16, balance left is 2. So we can write this as dx, because we have to bring it in the form x square plus a square root of x plus 4 the whole square plus root 2 the whole square. So this is going to be log x, that is log of x plus 4 plus root x square plus a square, which is nothing but x square plus 8x plus 18 plus k. So it's going to be log x plus 4 plus root x square plus 8x plus 18. Okay. Okay. Now here you have dx upon x square minus a square raised to half. So it's going to be the same way as we did earlier. So you take something like, say, dx upon root of x square minus 49. Suppose it's going to be log of x plus root x square minus 49 plus k. So we get it that way. So let's take some example based on this, wherein we need to have a perfect square expression. So again, we have something like this. So here it is going to be, we have x square plus 8x minus 18. So it's going to be dx upon x square plus 8x plus 16. Now you have taken out 16, hence you have to give 16, so it's going to be minus 34. So it has to be this way, x square plus 8x plus 16 minus 34, and this whole thing is under square root. Yes, so it's eventually dx upon root x plus 4 the whole square minus root 34 the whole square, 16. Okay, so now this is of the form x square minus a square root of that. So it's going to be log x, that is x plus 4 plus x square minus a square, which is x square plus 8x minus 18 plus k. Hence we have it that way. Okay, we have a couple more of formulae based on this. Okay, so now we have x square plus a square raised to half. So we have integral of root x square, say, plus, say, 144 is x by 2, that is x by 2 itself, into root x square plus 144, then a square by 2, which is eventually 144 by 2, 72, into log x plus root x square plus 144 plus k. Hence we write it this way. Okay. So be clear about the difference. The first two are not concerned with square root. The third and fourth were concerned with square root, but the reciprocal of the square root. And the last two are concerned with just the square root, not the reciprocals. So let's take a complex problem. For example, here you have x square plus 4x plus 9. Now this can be written as square root of x square plus 4x. The last square term in this is half coefficient of x, that is 4. Half of 4 is 2 square plus 4. You have removed 9. From 9 you have taken out 4, so balance is 5. It is square root of this dx. This is nothing but square root of x plus 2 the whole square plus root 5 the whole square dx. Remember, this is nothing but x by 2 into root x square plus a square, which is nothing but x square plus 4x plus 9 plus a square by 2. A in this case is root 5. Okay, root 5 the whole square, which is going to be 5 by 2 into log x, that is x plus 2, plus root x square plus a square, that is x square plus 4x plus 9 plus k. So hence we have this kind of thing. Okay, then we have another formula in this part, that is the last part, that is root x square minus a square. So it could be, say, x square minus 36 square root of that dx. So it's x by 2, that is x by 2 itself, root x square minus 36 minus, it's not plus, it's minus a square by 2, that is minus 36 by 2. Now since the minus is taken care of, don't take a as minus 36. Log x, that is x plus root x square minus 36 plus k. So this becomes obviously 18. Okay. Okay, so for example, here you have x squared plus 4x minus 9. So this is nothing but root x squared plus 4x plus 4. You remove 4, so you have to subtract, hence you get minus 13. This whole thing square root. So this is nothing but square root of x plus 2 the whole square minus root 13 the whole square dx. So it's going to be x by 2, which is x plus 2 by 2 into root x square minus a square, which is nothing but x square plus 4x minus 9, and minus a square by 2, that is minus 13 by 2, into log x. X in this case is x plus 2 plus root x square minus a square, x square plus 4x minus 9 plus c. Okay, so it's x plus 2 by 2 into root x square plus 4x minus 1 minus a square by 2, that is 13 by 2, log x. X in this case is x plus 2 plus root x square plus 4x minus 9 plus k. So these were all certain special type of substitution formulae, 6 of them, which we need to learn. So there are some examples over here. F of x is root 1 plus x squared, then integral of f of x dx is what? So it's going to be the last type, that is we are going to use 1 plus x squared, that is root of x squared plus a squared. So it's going to be 1 squared. So it's going to be x by 2 into root x squared plus a squared, that is x squared plus 1, plus log x plus root x squared plus 1 plus k. So it's going to be x by 2 root x squared plus 1 plus log x plus x squared plus 1 plus k. So it's going to be also a square by 2. We missed that a square by 2, which is going to be 1 by 2. A is 1, a square. So half log x plus root x square plus 1 plus k. So it's going to be option number B, right? So that is log x plus x square plus x. So option number B is our answer. Okay, yes. Okay. Then we have dx square plus 1 upon root x square plus 2 is equal to what? Let's see. Now this is an interesting thing. So we have x square plus 1. Now there is one root x square plus 2. Now if you see, x square plus 1 can be written as x square plus 2 minus 1. Why do we do that? Because dx. This can be now written as x square plus 2, which is nothing but root of x square plus 2 the whole square, upon root x square plus 2 minus 1 upon root x square plus 2 dx. This is now getting cancelled. So the first part is eventually root x square plus 2 dx minus 1 upon root x square plus 2 dx. So this is the formula using x square plus a square, where a is root 2. Here it is 1 upon x square plus a square, where a is root by 2. So now this is going to be x by 2 into root x square plus a square, that is 2, plus a square by 2. A is 2, so a square by 2 is 2 by 2, log x plus root x square plus 2, which is going to be this. Then minus 1 upon x square plus a square, which is going to be log x plus root x square by 2 plus k. Now ultimately this and this get cancelled, so it's just x by 2 into root x square plus 2 plus k. So it's x by 2 into root x square plus 2 by k, that is option number is. Okay, fine. So we should have our option right as A. Yes, okay. Okay, now we have 1 upon x square minus a square dx. This is a direct formula which is nothing but option number C, that is 1 upon 2a log x square x minus a upon x plus a plus c. That is option number C. Okay. Okay, using method of partial fraction, the integration of f of x when f of x is 1 upon x square minus a square is nothing but option number 2. But let's do by partial fraction since it's hard, just to brush up. So it's eventually 1 is going to be 1 upon whatever is going to be a upon x plus a plus b upon x minus a. So it's eventually 1 is equal to a into x minus a plus b into x plus a. Let x be equal to a. In that case, 1 will be equal to 2a, 2ab. So b will be equal to 1 upon 2a. Suppose x is equal to minus a. If x is minus a, then 1 would be equal to minus 2aa. So a would be equal to minus 1 upon 2a. So eventually it's going to be minus 1 upon 2a into x plus a dx plus 1 upon 2a into x plus a dx. Now this is a constant, so they will give you minus 1 upon 2a x plus a log x plus a and plus 1 upon 2a log x plus a. Now this is going to be x minus a. So this eventually would be nothing but 1 upon 2a into log x minus a minus log x plus a plus c, which is going to be nothing but 1 upon 2a into log x minus a upon x plus a plus k. So it's going to be option number C, which in any case we know is a standard formula we have used, but this is just to tell that using the formula has been derived by using the particular formula, the concept of partial fractions. I'm sorry. Okay.